Hello guys, I'm going to teach you how to solve circle questions by applying some teaching methods. But before start the new lectures, take a look at some exercise that we had homework on the previous lesson. Okay, so from exercise 5.1, the first problem says uh, the side BC and AD 12 and 8 centimeter respectively, and we have to find the radius of the circle. Okay, we know that AD, DE, CE, and CB, they are all tangent lines. So because of that reason, the length of CB is equal to the length of CE, which is 12. The length of AD is equal to the length of DE, which is 8. Okay. And we know that the tangent lines intersect circle at one point, and we are going to have the right angle, right? Which is 90 degrees. Okay. So here is, we're going to get one right a trapezoid. Okay, so that is AD, C, and B. AD is at 8. If I'm going to draw one parallel line to side DA, let's say it's D1, it's also 8. And the length of BC is a 12, so the length of CD1 will be 4. And what is the length of CD, which is 8 plus 12? It's going to be 12. And we don't know the radius. And let's say the R and R. So the length of AB is a 2R, and D1 and D parallel to AB. It's also 2R2. And we are going to use here the Pythagorean theorem for the triangle D1, and C. So 20 square is equal to 4 square plus 2R square. 400 minus 16 is equal to 4R square. 384 is equal to 4R square. And divided by 4, so 96 is equal to R square. When we take root of both sides, the R will be 16 times 6, which is 4 roots 6 centimeter. Okay, that is our radius. For the second problem, the length of AP and the measure of angle APB given in the figure. AP is 6 root 3. Okay, and APB is 60 degrees. But PA and PB tangent lines, and the common vertex between tangent lines PA and PB, it's a P. And if we are going to draw one straight line, PC passes through the point O. So in this case, we are going to have two adjacent angles, APO and BPO, or angle bisector. So the straight line PC divides angle P in two equal parts, which is 30 and 30, yeah. And after that, I'm going to draw one line from the center point O to the tangent point, which is A. We will have 90 degrees. OAP is a right triangle. 30, 90, it's going to be 60. Okay. Okay, let me write the vertices here. Okay, it's a 6 root 3. And we have to find the values OA. And we know that the sides which comes from 60 degrees is root 3 times greater than the side of corresponding angle of 30 degrees. So it means that if I'm going to multiply the side OA by root 3, we will get the length of AB, which is 6 root 3. They cancels each other out, so the length of OA is equal to just 6. It is the radius of the circle. For the next problem, we have two circles, small and the big. And here is the length of O1, O2 is 3 centimeter given, and the sum of the values is 11 centimeter, and we have to find the values separately. And let me take a 1 point over here, and let's say it's C, and I'm going to call the length of O2C as A. For the small circle, we know that AO1 and O1C is the radius, right? So the length of AO1 is equal to the length of O1C. So they are both 3 plus A. It is the first radius for the small circle. Yeah. And for the second, uh, the radius of this big circle is equal to the length of AO2. It will give us the second radius of the big one. So what is the length of AO2? It's gonna be 3 plus A plus 3, which is 6 plus A. Will be represented by R2. The sum of R1 and R2 is 11. So all we need to do is put these values into the original equation here. So R1 is 3 plus A, R2 is 6 plus A is equal to 11. 9 plus 2A is equal to 11, and from here we will get for A is a 1. And we have to find separately R1 and R2. If A is a 1, R1 is a 4, R2 is a 7. Okay. And finally, we are going to have our lecture, arcs and angles of a circle, arcs and central angles. By the definition, an arc of a circle consists of 2 points on the circle, A and B, the points on the circle, and the unbroken part of the circle between these 2 points. We use the symbol you're gonna see over here. And in the figure, we write arc AB to denote the arc between A and B, and the arc ACB to denote the arc ACB. Notice that any 2 points of a circle divide the circle in 2 arcs, arc AB and arc ACB. And their sum is 360 degrees, that is complete angle. If the arcs are unequal, the arc AB and the arc ACB, they are not equal. You can see that. The measure of arc ACB is bigger than the measure of arc AB. So how can we call the arcs? The small arc is called the minor arc, and the larger one is called the major arc. So we say the arc AB is the minor arc, and the arc ACB is a major arc. Another definition says an angle whose vertex is at the center of a circle is called a central angle of the circle. Yeah, A or B, the central angle. The degree measure of a minor arc is equal to the measure of its central angle. OA and OB. These lines come from the center points. So we say the measure of minor arc AB is equal to the measure of its central angle. You're gonna see here. Okay. So if it is alpha, which is central angle, the measure of arc AB is also alpha. For the next definition, we have a semicircle. The arc ACB, which is major one, that is a semicircle, and by the definition, we say the measure of arc ACB is 180 degrees because that is the half of the circle. The degree measure of a major arc is 360 minus the measure of the central angle of the minor. So the measure of arc CAB is equal to the measure of 360 degrees minus the measure of arc CB. Okay. Because we know that the measure of arc CAB plus the measure of arc CB will give us 360 degrees. By taking the measure of arc CB to the left, it will give us 360 degrees. For the next part, we have example 5.9. Find the measure of the indicated central angle of each circle. Remember that the measure of a minor arc is equal to the measure of its central angle. So if the arc AB is a 50, the measure of arc AOB will be here, the central, which is 50 degrees. Here, the measure of arc CD is a 120 degrees, and the measure of angle O is a central. So 120 degrees is equal to the measure of its central angle, which is 120. And for here, we are going to have 180 degrees. Okay. For the next definition, we have inscribed angles. An angle whose vertex is on a circle and whose sides contain charts of the circle is called an inscribed angle. BC and BA, two charts, and the charts intersect circle at points CA and B. So this angle formed by two charts BC and BA. In this case, the measure of angle B is called inscribed angle, and its corresponding arc will be intercepted arc. Okay. So there is a relationship between inscribed angle and its intercepted arc. And the measure of an inscribed angle is half of the measure of the central angle which intercepted the same arc. And for the next property, the measure of an inscribed angle is equal to the half the measure of its intercepted arc. So if the measure of inscribed angle CBA is alpha, the first property says the central angle will be 2 times greater than inscribed angle. So the central angle will be COA, and alpha times 2 will give us the central angle. So the measure of central angle is 2 alpha. What about the arc AC? And we know that the measure of an inscribed angle is equal to the half of the measures of the intercepted arc. So if it is alpha, so it's gonna be 2 alpha. Instead of this, if the measure of central angle is a 2 alpha, the measure of arc AC is equal to it is intercepted arc, so which is 2 alpha. For example 5.10, we have to find the measure of angle, the measure of x in each figure. For the first one, the measure of angle ABC is equal to the half of the measure of arc AC. So the measure of angle ABC is a 50 degrees. So the measure of arc AC will be 50 times 2, which is 100 degrees, which is the measure of angle X. For the second, the measure of angle ABC is equal to the measure of angle arc AC over 2. So the measure of arc AC is given 120 degrees. So what is here the measure of angle X, which is CBA? It's also the inscribed angle. We know that the inscribed angle is half of it is intercepted arc. So it's gonna be 60 degrees. For the last one, the central angle is given, which is COA. If the measure of central angle is 90 degrees, what is the measure of arc AC? It's gonna be 90 degrees too, right? They are equal. If the measure of arc AC is 90 degrees, what is the measure of inscribed angle, the half of the measure of arc AC, right? So the measure of angle X is equal to the measure of arc AC over 2, which is 45 degrees. For the next property, if two inscribed angles intercept the same arc, BC and BA, DC and DA, they intercept the same arc, which is AC, then the angles are congruent. So we say the measure of angle ABC is congruent to the measure of angle ADC because they both intercept arc AC. For example, if the measure of arc AC is a 2 alpha, how can we define the measure of angle ABC and ADC? They are both inscribed angles, so it will be the half of their intercepted arc, so they will be both alpha and alpha. For example 5.11, we are going to find the value of X and Y in each figure. For the first one, I want you to look at the inscribed angles, which is X and Y. They share the common arc, which is CD, right? So if the measure of arc CD is 40 degrees, the measure of X and the measure of Y will be half of their intercepted arc, which is 20 degrees. For the second one, the measure of angle BAC is equal to the measure of angle BOC is equal to the measure of arc BC divided by 2. So we say X is equal to Y over 2 and 50 over 2. And from here, we will get for X is 25 degrees and for Y is 50 degrees. For the last problem, the measure of angle BAC is equal to the measure of angle BOC divided by 2, the half of it. So if the measure of angle BAC is at 20 degrees, how can you find here the central angle BOC? The central angle measure is 2 times greater than inscribed angle here because they share the common arc BC. So BAC is a given 20 degrees is equal to the measure of arc BOC over 2. So from here we will get for angle BOC 40 degrees. So it's going to be 40, which is Y. And we know that BAC and BDC, they have the common intercepted arc, which is BC. So their measures are equal. If the measure of angle BAC is at 20 degrees, also the measure of angle BDC will be 20 degrees too. For the next property, we will look at the semicircle. An angle inscribed in a semicircle is a right angle. For example, in the figure, the measure of angle, the arc ALB, and is equal to the measure of angle arc AMB is equal to the measure of arc ANB is equal to 180 degrees. Then their measures are equal, which is 90 degrees. Okay, so it means that in a semicircle, if I'm going to tag any point on a semicircle, let's say here the point is a K. If we are going to combine the points, we are going to have here the right triangle. And let me take the point over here. Let's say L. And we will do the same thing, same story. By combining points BL and AL, we are going to have another right triangle here, which is 90 degrees. Okay. For example 5.12, Find the value of x in each figure. For the first one, since AC is the diameter, right? The arc ABC is a semicircle, so the measure of angle ABC is inscribed in a semicircle, and therefore the measure of ABC is equal to x, which is 90 degrees. Okay. For the second problem, we know that the measure of angle DAC is equal to the measure of arc DC over 2, which is 60 divided by 2 will be 30 degrees. Okay. It will give us the measure of angle DAC, which is 30. Okay. And after that, we know that the measure of arc BC is 2 times greater than its inscribed angle. So the measure of angle CAB is at 20 degrees. The measure of arc BC will be 2 times the measure of angle CAB. So it will be 40 degrees, which is Y. Okay. How can I find the value of X? ADCB, that is a semicircle, which is the arc will be 180 degrees. So we say the measure of X plus 60 plus 40 will give us the semicircle. So X will be from here 80 degrees. Okay. For the next property, the measure of the angle formed by a tangent, that is our tangent line, and the point A is a tangency point, and a chart S, which is AB, equal to half of the measure of its intercepted arc. So it means that if the central angle here, alpha, the measure of CAB will be alpha over 2. Yeah. If the measure of angle AOB is alpha, so the measure of angle CAB will be alpha over 2. Okay. For the next rule, the side AB and the side C, they are two charts and they are parallel to each other. And the measure of angle ABC and the measure of angle DCB, they will be alternate interior angles. And we know that from the previous lessons, the measure of alternate interior angles are equal. So if it is alpha, it's also alpha. Angle B and angle C, they are both alpha. What is their intercepted arc, AC and BD? If angle B is alpha, the arc AC will be 2 alpha. And BD is also 2 times greater than its inscribed angle, which is 2 alpha. As you see here, the measure of arc AC is equal to the measure of arc BD. For the next example, we have 5.13. Find the value of X and Y. Okay. Let me draw the radius OA. And then AC is perpendicular OA. It will be 90 degrees. It will be 90 degrees. So triangle AOB is isosceles triangle. The measure of angle OAB is 30 degrees, right? Yeah. Okay. We know that the sum of interior measures are 180 degrees in any triangle. So the measure of angle O will be 120 degrees, right? Okay. If it is 120 degrees, what is the measure of arc AB? The measures are equal, right? Because we know that the measure of arc AB is equal to the measure of its central angle. So it's going to be 122, which is y. What is the measure of x? So it's going to be half of the central angle. So the measure of angle CAB is equal to half of the measure of angle AOB, which is 120 over 2 will be 60 degrees. Instead of this, also we can use the complementary angle methods, which is x and 30. They are complementary. So if it's 30, x will be 60 degrees. We can find the value of x directly like that. For the next problem, AB is a parallel to side CD. There are two charts, and the measure of angle BAD is given 15, and we have to find the measure of angle DCE. Okay, first, we know that the measure of angle BAD is equal to the half of the measure of arc BD, right? Okay, so if this inscribed angle is 15 degrees, what is the measure of arc BD? It's gonna be 15 times 2, which is 30 degrees, right? Okay. Okay. And we know that the measure of arc AC plus the measure of arc CD plus the measure of arc DB is 180 degrees. Okay. So if it is 30, AC will be also 30 degrees. How can we do that? Because AB is parallel to side CD, right? If it is 15, the measure of angle ADC is also 15. If the measure of angle D is at 15, what is its intercepted arc? It's going to be 30 degrees. Okay. So we say that the measure of angle BD plus the measure of arc CD plus the measure of arc AC will give us 180 degrees. So the measure of arc CD will be from here 120 degrees. Okay. If it is 120 degrees, we know that the x will be the half of it. So the measure of x is 120 degrees over 2, which is 60 degrees. Okay. For the next rule, the measure of an angle formed by two seconds, a secant and a tangent, or two tangents drawn from a point in the exterior of a circle is equal to half of the difference of the measures of the intercepted arcs. Okay, the rule is really seems a little bit complicated. Okay, we will make it easier. In AB and AC, there are two tangent lines, and the tangents to point B and C. So we are going to draw a line from center point O to side the point B and another point C. And we are going to have here the 90 degrees because we know that the side OB is perpendicular, the side AB, and the OC is perpendicular, the side AC. Okay. So in this case, the measure of central angle and the measure of angle alpha will give us 180 degrees. So the alpha is the exterior measure. Okay, the exterior measure of a circle. So we have three positions. On the first one, the angle P formed by two seconds, PC and PD, they are second lines. So in this case, to find the measure of angle P is equal to the difference between the measure of arc CD and the measure of arc AB divided by 2. For the second shape, we have one second line, which is PD, PC, and we have one tangent line, which is PB. So in order to find the measure of angle P, we will take half of the difference of arcs, CB and AB. For the last one, PA and PB, they are both tangent lines. Remember the previous rule, the alpha plus beta will give us 180 degrees. So it means the measure of angle P is equal to the half of the difference between the arc ACB and AB, or the measure of angle P is equal to the measure of 180 degrees minus the measure of arc AB, which is P plus the measure of arc AB will be 180 degrees. Okay, the measure of angle P plus the measure of arc AB is equal to 180 degrees, because we know that the measure of angle alpha plus the measure of angle beta is 180 degrees. So if the central angle is beta, what is the measure of arc AB? It's also beta, right? Same. So the alpha plus beta will be 180 degrees. For the next rule, the measure of an angle formed by two charts, BD and AC, that intersect in the interior, alpha and beta, of a circle is equal to half the sum of the measures of the intercepted arcs. So we say the measure of angle alpha is equal to the measure of angle x plus y over 2, and the measure of angle beta is the half of the measure of arc A and B. Okay. For the example 5.14, the measure of angle BAD given 30 degrees and the measure of BED is 70 degrees. Okay, and we have to find the measure of angle X. BAD and the angle ADC, they are inscribed angles. So if it is 30 degrees, what is the measure of arc BD? It's gonna be 2 times 30 degrees, right? So it's gonna be 60. If the measure of angle ADC is x, what is the measure of arc AC? It's gonna be 2 times x2x. According to previous rule, it says alpha is equal to half of the x plus y, and beta is half of the a plus b. So automatically, the measure of angle 70 is equal to the measure of 60 plus a 2x over 2, right? And 70 times 2, which is 140 degrees, is equal to 60 plus 2x. And there's still work that needs to be done. We haven't finished. So 140 minus 60 is equal to 2x. 80 divided by 2 will give us the measure of x, which is 40 degrees. Okay. And also we can use another theorem to find the answer. If it is 30 degrees, this inscribed angle goes the arc BD, and also the measure of angle C goes the arc BD. They are equal measures, so it's also 30 degrees. And we know that the sum of two interior measures will give us one remote exterior, so 30 degrees plus x is equal to 70, and from here also we will get for x is 40 degrees. Okay. For the next problem, we have two second lines, which is AC and AE, and the measure of angle BCD 15, and the measure of arc CE is 100 degrees, and we have to find the value of x. And we know that the value of x is equal to the half of the measure of arc CE and the measure of arc BD. We will take a difference between the measure of arcs. So what is the measure of arc CE, which is 100, minus what is the measure of arc BD? If it is 15, what is the intercepted arc of this inscribed angle? So it's gonna be 15 times 2, which is 30 degrees, right? So 100 minus 30 degrees over 2, which is 35 degrees. That is the value of BAD. For the next problem, the exterior measure is given, and PQ and PR is the tangent lines. Q and R, the tangency point. So in this case, according to rules, we know that the measure of angle QPR plus the measure of arc QR will be 180 degrees, right? So if it is 60 degrees, what is the measure of arc QR. It's gonna be 180 minus 180 minus 60, which is 120 degrees, right? Okay, we got the first step. Okay, and after that, the measure of arc QR and the measure of arc QTR will give us 360 because that is the whole circle. And from here, we will get for the measure of arc Q2R is 360 degrees minus 120, which is 240 degrees. Okay. And we know that QSR is inscribed angle, which is half of the measure of arc QTR. So it's going to be 260 divided by 2, which is 120 degrees. Okay. And for the next time, I want you to solve problems from exercise 5.2. And for the next lesson, I hope I'm planning to solve some problems from exercise 5.2. Thank you. Bye-bye.